Let's look at section R.6 and do some similar questions to your homework. Question 1. Decide whether the statement is true or false. If false, correct the right side of the equation. Recall our formula for the negative exponent is x to the negative n is equivalent to 1 over x to the positive n. We can move this to the denominator and make this a positive exponent. This looks exactly the same. We're going to move this 2 to the 5 in the denominator, making it a positive 5. And so this is a true statement. This is a true statement. Question number 2. Let's evaluate this expression. Negative 9 raised to the negative 3. We're going to use our negative exponent formula. The negative 3 influences the negative 9. So the entire negative 9 goes into the bottom. We're going to change this to a positive 3 and a 1 is left on top. Now we can simplify negative 9 cubed with our calculators. And negative 9 cubed results in 729. This is negative 729 with a numerator of 1. Question 3. Write the expression with only positive exponents. Now you want to be extra careful. This negative 5 only affects the 3. So we're going to leave a negative 1 on the top and bring down that 3 to the positive 5 in the denominator. Now this can still be simplified as negative 1 over, and then we could do 3 to the 5th on our calculator. 3 to the 5th is equivalent to 243. So this is our solution, negative 1 over 243. Question number 4. Write the expression with only positive exponents and evaluate if possible. This negative 4 affects the entire 3x. So I'm going to write this as 1 over 3x raised to the 4th power. Again, it becomes a positive when we bring it to the denominator. And now we can distribute the 4. This 4 goes to the 3, and this 4 goes to the x. We can simplify the 3 to the 4th, that is 81. And we have a 1 on top. So our solution is 1 over 81 x to the 4th. Question number 5. We can divide and simplify the following. Recall x to the m over x to the n equals x to the m minus n. We have to subtract the exponents. This is a to the 15 minus 3 or a to the 12th power. And we cannot simplify it any further. We are done for question 5. Question 6. Let's perform the indicated operation. Write answers using only positive exponents. I'm going to start by dealing with the coefficients in front. We have the 4 and the 6. Let's reduce those both by 2. This gives me 2/3 in the front here. Now I can subtract these exponents. We have 2/3 m to the negative 2 minus 2. We're subtracting the m and the m. And then we have n to the 5th minus a negative 4. We're subtracting the n to the 5th by n to the negative 4. This reduces to 2/3 m to the negative 4th power. N, well, remember this is a double negative, so that's a plus, n to the positive 9th power. Now we're not done because I need to make sure there's only positive exponents. So let's bring this m to the negative 4 into the denominator. Let's rewrite this as 2n to the 9th over 3m to the positive 4. Make sure you bring all of the negative exponents to the denominator. Question number 7. Let's simplify the expression. Let's distribute the 4 to the 6, the 4 to the negative 1, and we'll distribute the 3 to the 4. We have this is 6 to the 4th a to the negative 4, because negative 1 times 4 is negative 4, a to the negative 12. We have 6 to the 4th is 1,296. And now we have a to the negative 4 times a to the negative 12. Recall, if I'm multiplying these exponents, we need to add them together. This is going to be added together. That's a to the negative 4 plus negative 12. And so that is equivalent to negative 16. We have 1,296 a to the negative 16th power. And again, I can bring this to the denominator. This is 1296 on the top and a to the positive 16 on the bottom. For question 8, let's rewrite this using only positive exponents. So let's distribute this cubed to this left side expression. We have 3p squared q times q cubed over 9p to the 5th q to the 8th. I'll deal with the top first. This is an exponent of 1. So this reduces to 3p squared q to the 4th, because we have 1 plus 3 gives us 4. I can cancel out the 3 with the 9. This becomes a 1 and this becomes a 3. Now we could subtract the exponents. This is 1/3 p to the 2 minus 5 q to the 4 minus 8. Let's simplify this as 1/3 p to the negative 3 q to the negative 4. Now, since these are negative exponents, bring them to the bottom. We have a 1 on the top, a 3 on the denominator, p to the 3rd, and q to the 4th. For question number 9, we are going to distribute the negative 2 to the 6 and the w, a negative 3 to the 6, and to this w cubed. Same thing here on the bottom. We'll distribute all of these exponents to their corresponding exponents. So let's take our time on this one. This is 6 to the negative 2, w to the negative 2. This is 6 to the negative 3. Again, there's an invisible exponent of 1. This is actually w to the negative 9, because 3 times negative 3 is negative 9. We'll put that over 6 to the negative 6, w to the negative 9. And now let's simplify the 6 to the negative 3 and the 6 to the negative 2 here. That's 6 to the negative 5. And we have negative 2 and negative 9. That's w to the negative 11 over 6 to the negative 6 and w to the negative 9. We'll subtract the exponents. This is equivalent to 6 to the negative 5 minus a negative 6, and w to the negative 11 minus a negative 9. Again, this double negative becomes a plus, this double negative becomes a plus. So this is 6, negative 5 plus 6 is 1, so we'll just write it as 6. And this is w, negative 11 plus 9, that's 2. So we have w to the negative 2. And of course, this is a negative exponent. We can't have that, so let's bring that to the bottom. This is 6 over w squared. For question number 10, let's perform the indicated operation. Recall x to the m over n is equivalent to the nth root of x to the m power, or we can write this as the nth root of x raised to the m. So there's two definitions for x to the m over n. Now I could rewrite this as a radical. This is the cube root of 1000 raised to the second power. Now you can enter the cube root of 1000 onto your calculators. That's equivalent to 10. 10 squared is 100. So we can do the radical first, then the exponent, or we can actually just type this whole expression into a calculator if we wanted to. We could do 1000 caret 2 divided by 3, press equals on a scientific calculator, and we'll still get the same answer. For question 11, let's distribute the negative 4/3 to each of these numbers. So this is equivalent to 8 to the negative 4/3 and 125 to the negative 4/3. Now notice that these exponents are negative. That means I can bring the 8 to the 4/3 to the denominator to make it positive, and we could also bring the 125 to the numerator and make that exponent positive 4/3. This is equivalent to the cube root of 125 raised to the 4th over the cube root of 8 raised to the 4th. And now we can simplify this. The cube root of 125 is equivalent to 5, and the cube root of 8 is equivalent to 2. We can raise 5 to the 4th power, that is 625, and 2 to the 4th power, that's 16. For question number 12, I'm going to add these exponents, x to the m times x to the n. We have to add the m and n. Now we have 8 to the 1/2 plus 3/2. That's equivalent to 8 to the 1/2 plus 3/2 is 4 over 2, and I can reduce that to 8 squared, or 64. Question 13, we want to simplify the expression. Here we're going to subtract, so this is 1000 raised to the 5 over 6 minus 3 over 6. This simplifies to 1000 raised to the 2/3, because 5 over 6 minus 3 over 6 is 2/3. And I can simplify this as the cube root of 1000 squared, and we have done that in a previous problem. That is equivalent to 10 squared, or 100. Number 14 looks like an exciting problem. We can rewrite this as these exponents distributed throughout. Same thing with the 1/2. And don't forget about the denominator. So this is going to take us some time. I can rewrite this as 256 raised to the 1/4, m raised to the 3/4. 3 times 1/4 is 3/4, over n to the 1/4. We're going to multiply that now by 9 to the 1/2, n to the negative 1/2, over m. 1/2 times 2 is 1, so we'll leave it as m. Now we can simplify some of these on a calculator. According to my calculator, 256 to the 1/4 power is 4, and 9 to the 1/2, we can write that as 3. So let's put 4 times 3 into the front. 9 to the 1/2 is 3. 256 to the 1/4 is 4. We have m to the 3/4, n to the negative 1/2, and then on the bottom we'll write n to the 1/4 m. Now let's simplify 4 times 3, that's 12, and then I'll subtract the exponents for the m. This is an invisible one. We have m to the 3/4 minus 1, n to the negative 1/2 minus 1/4. This is equivalent to 12m. Now what's 3/4 minus 1? Well, 1 can be written as 4 over 4. So this is negative 1/4 n. We have negative 1/2 minus 1/4. I could use some crack work over here. Negative 1/2 minus 1/4 is equivalent to negative 1/2. Multiply the top and bottom by 2. I have negative 2/4 minus 1/4, and that's negative 3/4. So we have negative 3/4 as our exponent, but we can't have negative exponents. So let's rewrite this as 12 m to the 1/4 on the bottom and n to the 3/4 on the bottom. For question 15, we have negative 3k in the front and we want to find the product. So let's distribute that. We have negative 3k times k to the 9/5 minus, we have negative 3k times negative 5k. So that's negative 3k times negative 5k to the 1/5. So let's simplify this. Remember, these are exponents of 1, but instead of 1, let's write that as 5/5 and 5/5 for the exponent, because we're going to have to add these exponents anyway. This is negative 3k. Now what's 5/5 plus 9/5? That's 14/5 minus negative 3 times negative 5 is actually positive 15k to the 5 plus 5. 5/5 plus 1/5 is actually 6/5. And it doesn't appear that we can simplify these exponents at all, and so we are done. For question 16, we want to factor out p raised to the negative 16/7. So let's factor out p raised to the negative 16/7 to the front, and then we'll have to decide what's left over. Now I know I want to end up with negative 2/7. So this has to be p raised to something where when we add them we get negative 2/7. If you look at this carefully, I need to add 14/7. 14/7 plus negative 16/7, if you add that together, is negative 2/7. That's how we get this back. So I know this is correct. Now I need a 2 because it's a 2 here. And we already have p to the negative 16/7, so I don't need anything else. So I don't need anything else. We'll put this parentheses a little bit closer. This is our factored form, but we can simplify that a little bit further. We have p to the negative 16/7 times p squared, because 14/7 is 2. And so we have to deal with this negative exponent. Let's bring that to the bottom. We have p squared minus 2 on the top and p raised to the 16/7 on the bottom. For question number 17, there's a lot of negative exponents, so let's deal with those first. Bring those all to the denominator. But be careful, there's an addition sign here, so you can't bring this to the bottom. You can't do that. So don't do that. Don't bring it to the bottom. There's an addition sign. There's a minus sign. We can do it if there's multiplications. So instead, I'm just going to write it as 1/x. 1/y, 1/x minus 1/y times x minus y over x plus y. Now let's multiply the top and bottom by xy, and that's to get rid of these fractions. xy times 1/x is y. xy times 1/y is x. xy times 1/x is y. xy times 1/y is negative x. Now notice here that y plus x is the same as x plus y, so we can reduce that and make that a 1. And we can simplify this as x minus y over y minus x. Now they look very similar, but they're not quite equivalent. So let's see if we can factor out a negative 1 from the top, and this will give us y minus x over y minus x. Now notice that it's negative 1 causes the numerator to switch around and become y minus x. Now we can reduce these. There's a multiplication between them, so we can reduce that to a 1 and a 1. So this actually is negative 1. For question number 18, let's rewrite this as a minus 9 over c. Again, this negative 1 only affects the c, over a minus 3 over c times a plus 3 over c. Again, these negative ones only affect the c. Now notice on the bottom we have the difference of squares. A squared minus b squared is a minus b, a plus b. So we can use our formula for the difference of squares. We have a minus 9 over c divided by a squared minus 3 over c squared. This simplifies as a minus 9 over c divided by a squared plus negative, negative 9 over c squared. Let's multiply the top and bottom by c squared to get rid of those fractions. This gives us ac squared minus 9c, because the c and the c squared, they reduce by 1. Then we have a squared c squared, and the c's reduce out, minus 9.